Ready.
This is ninth lecture of the class 12 maths. Today our topic is adjoint matrices. In previous class we find matrices, determinants. Now on last of this topic we discuss about the adjoint matrices. Adjoint matrices, if you have any square matrices, you want to find the adjoint matrices of A. You find cofactor of all elements and transpose the cofactors that you find one of the square matrices, that is called adjoint. That means you have given a matrices. Suppose that you have given one of the matrices, a square matrices is this. You go on to find the cofactors. You already know the cofactor. You find the cofactor -1 I plus j and minor. By this way you can find the cofactors. First cofactor will be in form of in row C11, C12, C13. If you transpose the cofactor, that it become in column C11, C12, C13, C21, C22, C23. Now, square matrices and its transpose cofactor multiply. Then you find this result. That means A11, C11, A12, C12, A13, C13. If you multiply A11, C21, A12, C22, A13, C23, that become the determinant of its 0. According to properties of determinant, if elements of row or columns be multiplied, the row or column of other row or column, cofactor of row or column of other, then it becomes the 0. Here you multiply first row and first column. This gives the value of this value will be determinant of A. But this row you multiply the second cofactor of second column, it will be 0. Similarly, third row, first row multiply with third column, it will be 0. Next, second row multiply with the cofactor of first, that will be 0. If second row multiply the cofactor of second column, it will be the value of determinant is A. On second multiply the third column, it will be 0. Similarly, you find if you multiply in the same format and find the result of this, you take the common determinant A and find the identity. That means multiply a square matrices A and adjoint A, result will be determinant A and identity. Now you go on properties. All the if a square matrices is null matrices, adjoint of this will be 0. A square matrices be identity adjoint of this be identity. Adjoint, if transpose the adjoint matrices of A, you find the same result. The transpose of adjoint, you find the transpose of matrices A with adjoint matrices. If A is symmetric, adjoint A is symmetric, you find the determinant of adjoint matrices A. Result will be determinant A power n minus 1. Here n is the order of square matrices. If third order, you write the 3, two orders, write the 2. Adjoint matrices or the product of A and B that result same as the adjoint of B into adjoint of A. If find the adjoint of adjoint matrices A, result will be determinant A power n minus 2 into A. N is the order of matrices. Now, you take one of the problem and verify your result. That means your result is A into adjoint A equal to adjoint A into A equal to determinant A with identity. Now A is your square matrices. You find in previous class, you find the determinant in previous class, it will be 11. Now cofactor of all the elements of these elements of square matrices, you take the first you deleting the row and column. Now rest of the elements 0, 0, minus 2, 3, minus 2, 3 and cross multiplication, you find the result 0. You take the second element for finding the cofactor, you deleting the column and row. Now rest of element be 3, 1, 3, 1, minus 2, 3, minus 2, 3. And this position is 1, 2, odd position, so you write the minus and multiply 3 into 3, 9, minus plus 2, 9 to 11 and write the minus 11. Now similarly you find the cofactor of the all elements of given square matrices in the same way. You find the result of this. First element has 0, second minus 11, third 0 in first row. In second row 3, 1, minus 1. Similarly third row have the cofactor of these. Now you transpose these cofactor and find the result 0, minus 11, 0 in row, you write its column after transposing. 3, 1, minus 1 in row, you write in column 2, 8, 3, 2, 8, 3. Now, square matrices A and adjoint A multiply. You know the rule of multiplications. You take the row of the first matrices and column of the second. 1 into 0, minus 1 into minus 11, plus 2 into 0 and find the result 11. Similarly, you multiply second row with the first column, you find the result 0. Third row with the first column, result is 0. Similarly, first row in second column, result is 0. Second row with second column, result is 11. In this way, find one of the square matrices in which you find the common is 11. Now, 11 is the determinant of this square matrices, and determinant, this will be identity. Just you prove A into adjoint A equal to determinant A into identity, that you have verified. Now, you can find the inverse of the matrices by the same way. You learn here A into adjoint A equal to determinant A into identity. If you multiply A inverse on the both sides, adjoint A inverse determinant A into identity, A inverse A becomes the identity, adjoint A inverse determinant A. Now, A inverse will be adjoint A by determinant A. By this way, you find the inverse of a square matrix. You first find the inverse of any matrices. First you find the adjoint A and determinant A. Adjoint A divided by determinant A, that will be inverse of a square matrix. Suppose that in given problem you can find the inverse of matrices A inverse equal to adjoint A. Adjoint A, you have your adjoint is 0, 3, 2, minus 11, 1, 8, 0, minus 1, 3. Determinant A is the 11. Determinant A is the 11. Now you divide it 0 by 11. That means it is 1 by 11. You multiply all the elements by 1 by 11, 0, 3 by 11, 2 by 11, minus 1, 1 by 11, 8 by 11, 0, minus 1 by 11, 3 by 11. This is inverse of that square matrices. By this way, this method, you can find the adjoint and inverse of any square matrices. Thank you.